over 3 plus c. Oh, that was nice. That's right. This homework started with integrals, right? Great practice for the test tomorrow. They're kind of all mixed up because, I mean, number 10 was an arctangent. Number 20 was an ln. You find your u prime. That was nice. Number 26, though, oh, logistic growth. High logistic growth. Letter A, 5,000. Is that your L? Letter B, 2,500. Is that the population when it was growing the fastest? I see that nice half of L. Letter C. Oh, did you just have to find the rate at which, or the fastest rate? Just plug in 2,500, the number, into the differential equation, because the differential equation is not based on time, but based on number. And you get, oh, rough, 62.5 individuals per year. Guys, on the test tomorrow, could you have fractional parts of people? Looks like it. Well, I know, but on the test and the answers, could you have decimals? Yes, just don't be confused by it. Don't be confused by it. Don't, like, choose none of these just because they didn't round. They're using fractional pieces of people. Awkward. Number 34. My voice is dying. Can you guys just look at it? Sorry. I'll get my voice back to answer questions. And then you have your lice minus licked. You guys can see how they plugged in their clue. They had an initial condition, aka they had a point, a quantity at a time. So they found their C and then lice minus licked. Oh, check it. L and K are needed to both contribute, right? Wait, why didn't they round it? I thought, I mean, they did like 0.5 up here. I mean, they're only doing one decimal place. Why all of a sudden are they leaving like 4? Because if you're using one number to possibly get another, don't we leave as many decimals as possible to avoid error in math? We're not doing sig figs all along the way, right? Okay. Letter B. Final answer would be, now they rounded on this one. Okay, fine. I don't know. 82.8, aka about 83 years. Towards the end of the 80 seconds, we could say more like 83 years. Whoa, whoa, whoa. No, I tried this math and it was impossible. I set this equal to 250, the limiting constant, and I got that. ln of 0 doesn't exist. Come on, there are some people out there. There was 2 of you yesterday after school. You set it equal to 250. That's the maximum. That's the carrying capacity. But pause. Isn't 250 graphically a horizontal asymptote that mathematically it would never meet or never hit? Of course the math says 250 is impossible. But the nature doesn't exactly follow the math in that way. How do you get closer to 250 from 220, 230, from 230, 240, from 240, 249, from 249? 249.9? Can you have a 0.9 of something? No. If there's 249.1 or 2 or 3 or 4, it would round down to 249. But as soon as you hit 249.5, if you're talking about population, what technically has just kind of happened? Somebody was born, not a half of them, but a whole of them. You round up. So if we go to 249.5, that's where it has gotten to the point where we would say, oh, hey, it's basically reached it. So wait, in real life, is there maybe like a bouncing that occurs of maybe having a few more than the carrying capacity and them dying off because of like the environment not being able to sustain them? And so if population growth is logistic, you're not literally going to have like 0.5, 0.6, 0.9, 0.99 of a person born. That doesn't make sense. It's not for infinity. Anyway, there's some of this like clashing of math and reality right here. So I apologize, it was weird. I don't think there's anything like that in the test tomorrow. But 250 is a horizontal asymptote. Mathematically, I can't solve for it. But 249.5, which would round to 250, oh, I can solve for that. That was the craziness that occurred in that problem. And then you have B, and then you have B, and then I think we're done with that homework. Logistic growth, anything I can answer, specifically like directions, where it led, the math, where you got stuck, the concept, what it meant. The Endeavor card you better have memorized. We should have had an Endeavor card quiz, like we had time for that. But question, what are the endeavors from this chapter? Euler's, integration by parts, And logistic growth. Oh, dang, we really should have had an endeavor quiz. If only we had time for that. Okay. Do we need to study some endeavors, some concepts for tomorrow? Whoa, whoa, whoa. Eyes on me, eyes on me, eyes on me, all my people. Kyrie, eyes on me. Do you need to memorize things for tomorrow? Yes. For kind of like the first time all year? Yes. Some of you have needed to be memorizing earlier. But, okay. The new stuff. Oilers, integration by parts, logistic growth. Yeah? Okay, no questions on logistic growth. We're okay. Okay. Let's talk about the test so we have details, and then some of you guys are just going to work on the review, and some of you have questions for me on the review. The review, as always, the answers are online. So, the test. The first question you should be asking me is whether or not I am still of the persuasion that you're allowed to have your calculator. Are we allowed to use a calculator? Please. Oh, my textbook, yeah. Thanks, slide it out, that one. Just put the remote and the pen. Thanks, Dad. Okay. The test tomorrow. I think I already told you there are 19 questions, the last 2 of which are bonus, one of them being looping. Looping. I have given hints that this should be applicable to everyone who's asked to do their test tomorrow. Hey, test tomorrow. Wait a minute. I'm not going to be here. So you walk in the door, you put your phone up like always, and then normally what do you turn in? Because I start grading them as soon as you start the test. But I'm not here. I'm in Seattle. So now what? Why turn them in? Oh, because you're going to come in during break and, well, I am coming in. We have an in-service day on Monday, so yes, I have work on Monday. However, in some ways, but in some ways it allows you to have a 4-week break. Because if staff didn't have professional development as an excuse for us not starting school, then we would technically be having school till Wednesday. Oh. So, we suffer one day so that we can all enjoy it. And fun. Thank you. Thank you. Love you all. Okay, so, coming back. You're not turning in the homework spiral or the notes tomorrow. So there's no point in doing, you are when we get back, but you're not turning in tomorrow. So I can catch up on all the things I didn't have ready for tomorrow and just work on the review tonight? No, maybe that's none of you, maybe that's some of you. But listen, did you hear me? Yes. Yeah. What should you do for tomorrow? The review. Focus on the review. Get it in Google Classroom on time. Everything else is already late. Why not? Now, if you have time, sure, go do all the homework for the entire chapter. No one should be behind the entire chapter. We'll take notes for the entire chapter. Ryan, maybe it's still beneficial to take notes for the entire chapter. But I'm not grading either of them tomorrow. Ryan,
I was gonna say, can I take notes on like what you're about to say about the test on my phone?
Yes, you may. Thank you for asking. I appreciate it. Okay, so I already gave a hint at slope fields. You might be. Oh, I didn't make it dark. Hey guys, if the directions, I should have made the apostrophe dark, and I meant to, and I didn't. If it says match the differential equation, and there's a y with a little mark, that might be a dirt mark. Do you think it's probably a y prime if I say differential equation? Okay, so y dirt mark is y prime. Is that okay? Okay. Differential equation, it's a y prime. It's a differential equation. So y prime. Okay, anyway. Slope fields you're matching. You're solving some initial value problems. Basically, you're given differential equations, either doing indefinite integrals to solve or indefinite integrals with the plus c clue. Remember, if they give you a clue, you should find the plus c. Which means, should you remember things like use of and things like trig rules backwards? Yes. Could you be matching a differential equation with a graph of a differential equation, or an original equation with a graph of an original equation? Remember, slope fields, section 7.1, matching differential equations. You look at the slopes, but the y equals, you follow the flow. That sounds so like New England. Then, pretty much for, I should not say the rest of the test. The majority of the rest of the test is just solving integrals. What kinds of integrals? I don't know, like use of ones, or like hey, here's a substitution, you should probably do it to solve. Or, what do you do if you have an ln in an integral? separation, tic-tac-toe. Oh, it might be a tic-tac-toe-toe. Either tic-tac-toe or tic-tac-toe-toe. Sorry, I tried to do the whole thing in my head, but I might have gotten lost. Oh, it's a tic-tac-toe-toe. Sorry, just kidding. Don't forget your plus C. Just kidding, you're matching. You should be fine. Separation of variables. How does it work? All the X guys on that side, all the Y guys on that side, all the T guys on that side, all the Y guys on that side, right? And if they give you a clue, that C should be solved for. P.S. guys, I see a few different little exponentially growth ones. A few meaning like 2. One has words and the other one is just a differential equation that will get you an e to the kc plus c or an e to the kx plus c. Don't forget how to create sense. How do you rewrite that? What do you do if you actually have a clue? Plug it in, right? That was after like integration happened, after separation happened, and all that jazz. If you don't show your separation perfectly in multiple choice, I probably won't take points off, even though I should, because it's multiple choice. But in a long answer, I'm just kidding, they're all multiple choice, but I'm giving you space to work on certain ones. Oh, there's a partial fraction one. No, like literally, guys, it's just make the partial fraction. Like literally, like not even an integral. But what trick do you think it uses? And do you think there might be an integral somewhere else that needs partial fraction decomposition?
Yeah.
Do you remember what most of the answers looked like when there were lns? How many lns? Sometimes multiple, but what did we always get to do to them? So if you see multiple choice answers with an ln and lots of pieces, there might have been partials before. What else? What do you always do if you have an improper integrand, an improper fraction? Improper. Doesn't that mean top heavy? Top heavy. Isn't that when the degree of the top is, listen carefully, greater than or equal to? Greater than makes sense. Top heavy. Greater than makes sense. What doesn't make sense? Or equal to. Logistic growth. No spoilers. Loopy. Fun. Anyway, those are the two books. You got the loopy hint, sure, you can do that too. The loopy hint and then the, that'll be fun. Sound good? With that logistic, guys, one of them does have a differential equation. Remember, there are 2 different ways it can show up. Endeavor number 6 has both, and one of them has a less minus split. And you might be wanting to go back and forth depending on what the question asks. There's a random CalcBC practice test. Repeat this one. Critical numbers increasing, decreasing. Oh, just kidding.
The grades start dropping.
Well, that was fun. All right, guys. Does anybody have anything on the review they want to talk about? It could be a problem you haven't done, but you look at it and you're like, what's your shit? 23? 43. Thanks, good. Anything else? I'm pulling it up in Google Classroom just because I think all of my possible books are out and about. Well, that's not you guys. Sorry. Well, that's not you guys. That was the last call? 43 is the only one? Yeah. Okay, I'll do 43 first. If someone finds something else, let me know. 43. Hey, matching differential equations with slope fields. That's nice. 43. Euler's method. Nice. Good job, kid. right? I think they're from different places. We'd have to look it up to make sure.
What was Euler's first name?
Leonard.
Leonard.
Leonard. It has an H in it.
Swedish.
Like Mrs. Leon, but with a heart at the end, so Leonard.
Probably Swedish or German or Euclid Greek.
That would make sense. And the different pronunciation. Different languages do have different pronunciations. That's a thing. Just kind of weird for us. It's all Greek to Oh. I see an Euler's method.
Don't go to the picture. I thought you said take notes for me. What? You said take notes for me. I was trying to.
I can do an equals for the first one because they told me what that point was. I have to have a starting point or else I can't do anything. I have to be on the curve and then go tangent line to tangent line to tangent line to tangent line. Oh, so many cool things I've learned about this one. I already taught it. It's okay, maybe someday we'll try to tie like all of calculus together, which is pretty cool. But we're supposed to be getting to 1.3, so right away I can kind of make myself a roadmap and say, hey, you're going down to here, and I'm like, sweet, let's go. My dy dx is going to be pretty important because when I go doing Euler's, aren't I really just doing lots of linearizations building on top of each other? Yeah. So linearizations, okay. We can review that real fast. L of x, which is used to approximate f of x values, I mean, fairly okay-ish. Okay, not really as soon as you get far away, it's really bad. But don't we do like a, let's see, f of x1 plus f prime of, and this is really just a delta x. So I just need a y value. I have one to build off of, and then I just need a slope. I have a whole formula of them. Using the previous point, so 1 plus 1 is 2 minus 1 is 1. And I need a delta x, which they give me. Oh, isn't that nice of them? And so my approximate for that guy, don't worry, the approximate's there. I can say the approximate equals 1.1. But then when I get down here and it's time for me to build again, I need to build off of that previous y value that I got, plus the differential equation, 1.1 and 1.1. 1.1 plus 1.1 is 2.2 minus 1 is 1.2, right? Times 0.1? Are we okay, so? Yeah. So then 0.1 is going to 0.12, so 1.1 plus 0.12 is going to be 1.22, I think, right? I would usually line it up to be like actually super safe. Yeah, 22. Got it. And then I have my 1.22 plus my, my 1.2 plus 1.22, so 1.42 minus 1 is 1.42 times my 0.1, which is going to be 0.142. So I have 1.362 as my final approximation for f of 1 point. Double check symmetry. How's he looking? Hey, Jen, coming back to you in the next question that you found. But first of all, I never actually answered for you whether I am still firm on or resolute on you getting a calculator. I guess possibly be helpful. Okay, you're allowed to have your calculator. But can you guys just listen to? Some of you have. I'm not sure sneaky is the right way of saying it. Are there a lot of big, maybe even heavy, conceptual understandings, procedural masteries, or at least abilities that you have to have for this test, whether or not you have a calculator? Yeah. So if you get down, like you've done the entire test, you've rocked every single one, you have one last one, like one indefinite interval that you have to solve, could you theoretically start making definite intervals and doing testings in your calculators in order to kind of make it match as to which one makes sense? Yes. You can do a lot of discovery, experimentation, whatever. But if you start that early on in like problem number 3, are you ever going to finish that test? No, you have to make it all the way through the test without trying to misuse your calculator because it's going to slow you way down. Does that make sense? If you have tons of extra time at the end and to make your best guess, you get to play a little bit and see whether or not you can make it match with your calculator when you weren't supposed to really use your calculator on that question. I don't know, it's going to be okay, but if you're like on problem number 6 and class period is over, Mrs. Ashdale should not have to like stay in here all of lunchtime. Does that make sense? So please try to give her at least time to go to the bathroom. I mean, usually I just stay in here and I just suffer hunger, dehydration, whatever it is, and because I haven't left my room all day. But for her, please at least give her 5 minutes. So hold on, I told her to start the CalcBC test at 12:50, right? Okay. Can you guys try to be done by 12:40 no matter what? Does that make sense? So you get an extra like 10 minutes. Is that cool? I'll give you 2 extra bonuses. You can totally skip them if you want. Okay. Just because I know some of you, and you're like, my calculator, I can look at my forever cards that are loaded in my calculator. I can, okay, whatever. At this point, I don't care. Because if you don't know how to do this stuff, nothing's going to help you so good. Last year, there were some people that loaded all their forever cards into their calculator. I don't know how, I don't know how much time it took, I don't know how much typing. Do you guys know that people save like Avogadro's numbering program was in their calculator? Imagine that, and imagine someone like trying to get. What's the point? You have the AP where you can't even have your stupid calculator. And my final thing has the anyway. I don't know who did it, and I don't know who still has it, and usually I don't allow a calculator if it's not needed, but it is what it is. Okay. Be the rock stars I know you are. Solve the test to the best of your ability, and if you have a little bit of extra time and a problem you're stuck on, you can be creative with your calculator. Sound good? Okay. AJ, you had a question though. What's your question, kid? Ha! Nice. Is that a logistic differential equation? Oh no, it's just a differential equation. Even better. This one's logistic. Whoa! How did I, really quickly, might be helpful for you tomorrow on the test, know the difference between a logistic differential equation and a non-logistic differential equation. They're both super similar. They both have dy dt, and they both have like this guy, v plus or 1 minus y. What's the big, huge difference as to why Newton's law of cooling is not differential logistic growth?
There has to be like a variable.
I need a variable here and here for logistic growth. What's different over here? Just here. This differentiation, this integration by separation of variables, so much easier than that one. That one needs partial fractions because I have to take both of them over. This one, I just have one guy. ln, anybody?
Do you have to memorize the Newton's membership formula for small?
No. Don't memorize the Newton's formula. If I ever do give homework problems on random things, not random, like applicable, but something I don't spend a lot of class time on, if I ever give homework problems, Lorenzo, I'm just exposing you to like, oh, cool, this is an application. No memorizing of Newton's. Okay. AJ, let's see what's going on. Velocity. With an initial condition. Super nice directions. Check this out. They're not like trying to trick me by talking about the particular solution that maybe I can't even possibly solve. They say, nope, you gotta solve. So, okay. I gotta solve this differential equation. AKA, the only way to get v over is to take that entire binomial over. But I can leave this -2 to join with this dt. Now, mental math. Use sub tomorrow. Good skill, don't make a mistake. This one, not many mistakes you would make. But it's just going to be good old-fashioned ln of v plus 17. Because I ignored the chain rule? No, because u prime was just 1. that was a 2v, what would I have put in front? 1/2 to offset the u prime of 2. Show your work if you need to, okay? Equals. How to get rid of an ln? How do I rewrite the plus? And I end up with, is that good? Sorry. So my v can be a v of t, and then my 17 can go over there. That's just making it like more memorable for you guys. Like, oh, it's the velocity when time is. I can plug in. Oh, but wait. I'm supposed to find an expression. Maybe I need to. If they ever give you a clue, ever, there should not be a c remaining, right? Be careful. If you're matching answers tomorrow and you're like, it's good enough. I didn't solve for c, but just be careful. So, negative 47 is when, 0. Anything to 0 is 1. Add 17, careful, is 1. Add 17, I end up with negative 30 is equal to c. Do I have an expression for a? Yeah, I do. Sorry, not 1. V of t is equal to negative 30. Exponential decay technically because of the negative, but be careful. Sometimes you can have something like an ln of 1/2 that doesn't look negative, but really is. And so, I don't know, but this one, it's a negative 2. Like, I know 2, it's a negative 2. It's okay. ln, sometimes the negatives get hidden a little bit with fractions. Terminal velocity. Ooh, terminal velocity. Oh, it's just a horizontal asymptote. How do I find a horizontal asymptote of an exponential function? I thought exponentials go forever. It's not growth. It's decay. But as t decays away, what remains? This is one of those weird ones where the limit as t goes to negative infinity would be negative infinity. But as t goes to positive infinity, this guy's the weakest. Strongest is the 17. Limit as t goes to infinity is the definition of a horizontal asymptote. A horizontal asymptote exists at y equals L if the limit to infinity is that L. Yeah, some of those old-fashioned. But yeah. You can also, AJ, you can think about it as plugging in infinity, but right now this one's hard to plug in infinity or even think about. So you could rewrite it. Be negative 30 over e to the 2t, and life might be a lot easier because it's like, oh, that goes to infinity, that whole thing goes to 0. And then 0 minus 17 would be the negative 17. Now be careful of your units, I was being lazy. Velocity is feet per second. Yeah, you can think of it that way, or even just as a fraction, if you were to rewrite that negative exponent, the bottom wins, that whole thing's. He's just staying 30, but he's going to infinity. Right. So that's what I would yeah. Let me see. What's that snazzy term that we learned this year about comparing the degrees, the magnitudes, and behavior model? Is that it? Maybe? Anyway, doesn't matter. Let her see. It is safe to land when her speed is. So it could be negative because she's coming down. Negative velocity is 20 feet per second. At what time does she reach this speed? Plug it in. So I could plug in 20 into my velocity equation, which is, up here, negative 30. Yeah, so I could add 17 to be 37. I would divide 37 by, now, hold on, something funny is going to happen. I'm going to have 37 over negative 30 equals e to the negative 2t. How do I solve? Well, yeah, ln. But the problem is, guys, what kind of value is that? That's a negative. Can I do ln's of negative? No. That's quite intense. everybody? Oh no, I'm allowing you guys to use the calculator tomorrow. I'm just warning you, don't try being creative with your calculator and kind of cheating the system in the sense of to solve this one number 3 when you have 17 more to go. I mean, not literally 16 more to go. 2 of those are optional, 14 more to go. AJ, do you have the answers there real quick? That's okay. I got it right over here. It's number 69. Oh, it's in the back. Is anybody with the book able to look at number 69, letter C?
1.151. It says t equals ln of 10 over 2.
Yeah.
So you got, oh, it says negative 20. You did positive 20.
Where?
C. You did positive 20. It says negative 20.
Oh, because she is going down. Thank you. So it shouldn't have been plus 17. Okay, that makes sense. Plus 17 would be negative 3. There you go. Then you're going to add your 10, right?
Yeah.
So you can divide by your negative 30. Yeah, that makes more sense mathematically. Good. Which is going to look different, AJ, because they took that negative and they said, oh, hey, I can put that negative as a out here, and then I can put it as a up here, and I can make it ln of 10 over 2. But careful, it's ln of 10. But you could have just plugged in ln of 1/10 divided by negative 2, because this is a negative number divided by a negative is a 4. They just made it a little bit nicer. Yeah.
So this, can we do number 21?
Yeah, I'm ready. You guys okay? Ish?
Yeah.
And it's going to be a time, so then in seconds, right? So number 20 what, John?
21 under.
Loopy. Oh, come on, Loopy, all you gotta do is just make the terms match. I mean, make the integrals match.
Like, I'm having trouble going after I use like the.
What did you make your U, just so I can be going the same way? Because it could be either one.
E to the 3x.
I always write him over here because it helps me when I finally make a match to combine. Just helps me stay oriented. Minus and negative is a plus, and then doesn't match, so I can't put them together yet. But if I go again, for the whoever's listening, whatever you start with, you gotta keep going with, or else it's gonna go right back to where you started. And this is where it's gonna be a little funny. I need my ultraviolet voodoo to have this 3 distributed. So it's going to be UV times 3, right? So it'll be plus, because it was minus and negative, 3. And then minus, because there's no negative offset. And then a 3 times 3 is 9, times the integral of e to the 3x. Have I made my integrals match? Yes. But what I need to do is combine my terms, aka add that matching it kind of loop. integrand match so I can combine my terms to get 10. Unless I've made a mistake, if so, call it out.
I'm just confused.
But what I see, I did one integration by parts, uv minus v du. I did another integration by parts, which makes it return to the form of the beginning, because ease and trig will eventually loop. But I need to literally get this guy algebra, good old-fashioned algebra, add him to the other side, because like terms can combine. 1 plus 9 is 10. And I have over here this guy, which my final step is just to say, well, I'm going to solve for this guy. That's this guy. Why not just divide by 10? Who? Everybody, aka him and him. Just don't forget, it's an indefinite interval.
When you did the first seven, what happened to the 3 in front? Like, I know, I get it, like.
I just, a 3, it's UV, ultraviolet, and then voodoo, VU. So negative cosine times 3 e to the 3x. So I put everything with variables inside the integram, but 3 was a constant. This isn't the formula, I just pulled it out. So that's an the coefficient that I can pull out.
Oh, and it's minus.
It's minus the integral of VD. Yeah. Because at the very beginning, this is what I wanted, and dividing by 10, it's this crazy, like, I thought I always had to solve. No, he knew. Okay? I'm here till 3:45 if you need something. If you just want to come in and do some volunteer humanitarian outreach to ACT. Humanitarian aid. Come on, they're human. Give me help. Andy, bye guys. Yeah.